Math is a wonderful thing. Math is a really cool thing.
Alright, here's now the second part of our elimination video. From the first part, we learned that a variable can be eliminated after adding or subtracting the two equations, but only if we have matching terms, meaning if we have opposite terms or identical terms. But not all systems will have a matching terms. So here's an example. Note that my x variables are not opposite terms or identical terms. Same thing with the y variables. These two are not opposite terms or identical terms. So even though we are going to add the two equations, we will not be able to eliminate either the x nor the y variable. When you add 2x and 4x, you are going to get 6x, and here you will get 4y equals 24. Now, we were not able to eliminate the x or the y variable. Same thing if you're going to subtract. We'll get 2x minus 4x is negative 2x. Y minus 3y is negative 2y. 8 minus 18 is equal to negative 10. Again, none of the variables were eliminated. So how are we going to deal with this type of systems using the elimination method? We can multiply one of the equations by a number of our choice so that we'll be able to create a matching terms. In this example, the bottom equation has a 3y. If the top equation is multiplied by negative 3, then the first equation will have a negative 3y. After that, once we add, we'll be able to solve one of the variable. So let's try that. So if I'm going to multiply the first equation by a negative 3, we will end up getting negative 3 times 2x is negative 6x, negative 3 times y is negative 3y, and then negative 3 times 8 is equal to negative 24. And once we add the two equations, we were able to eliminate the y variable. So negative 6x plus 4x is negative 2x. Negative 24 plus 18 is equal to negative 6. Divide by negative 2, we'll get x equals 3. Once we have a value for one of the variables, we can now use either one of the equations to solve the other variable. In this case, I am going to use the second equation. So 4 times x plus 3y equals 18. 12 plus 3y equals 18. Subtract 12, we'll get 3y equals 6. So divide 3 both sides, we'll get y equals 2. So our solution will be 3 comma 2. So in this case, the system has a point of intersection, and that intersection is 3 comma 2. So we have one solution. Okay, let's have another example. On this example, let's look at the x variables. We can create a matching terms here if x will be multiplied by negative 4. So let's multiply both sides by negative 4. So negative 4 times x will give us negative 4x. Negative 4 times 3y will give us a negative 12y. 10 times negative 4 is equal to negative 40. We'll just copy the second equation. And as what we have planned earlier, we were able to create a matching terms in terms of the x variable. Well, in this case, we have opposite terms. So once we add these two equations, we will end up getting negative 10y equals negative 20. So when you divide both sides by negative 10, we'll get y equals 2. From here, we can either use the first equation or the second equation. So this time, I'm going to use the first equation. So copying the first equation, we'll get x plus 3y equals 10, but our y is equal to 2
equals 10. So we'll get x plus 6 equals 10. X equals, subtract 6 to both sides, we'll get x equals 4. So here we have
a point of intersection, and that intersection is 4 comma 2. Of course, you can also use the second equation. So let's show we will be able to get the same x value if we are going to use the second equation. So let's show that right now.
4x plus 2y equals 20. We're able to get y equals 2. So let's replace our y by 2. So this is equal to 4. Subtract 4, we'll get 16. So 4x equals 16. So divide by 4, we ended up getting x equals 4 also.
So again, it does not really matter. As long as you have a value for one of the variables, you can now use any of the equations. Alright, so in this method, we're able to eliminate first the x variable. Now, it's also possible that we eliminate the y variable first. So let me copy this. This is what we did earlier. So we eliminated x. Now let's say you would like to eliminate y. So the coefficient of my y here is 3, and on my second equation the coefficient of my y is 2. So your goal is to make this as a matching term and make the other one negative. To have a matching terms, we are going to use the LCM of 3 and 2. The LCM will be equal to 6. Okay, so it means that we are going to make this equal to 6. Same thing with this. We are going to make this equal to 6. So how can we make this equal to 6? Multiply by 2. So you will get 2x plus 6y, and 10 times 2 will be equal to 20. Okay, now how can we make this equal to 6? Multiply by 3, correct? But then I think it's better if we multiply this by a negative 3, so that we'll end up getting a negative 6y here, and then once we add the two equations, the y variable will be eliminated. So negative 3 times 4x is negative 12x, negative 3 times 2y is negative 6y, negative 3 times 20 is negative 60, and once we add the two equations, we will get negative 10x. Y has been eliminated. 20 minus 60 is equal to negative 40. Dividing both sides by negative 10, we are going to get positive 4. Okay, note that it's the same value for the x that we got earlier. So once we have a value for one of the variables, we can use either the first equation or the second equation. So let's use the first equation.
X plus 3y equals 10. But our x is equal to 4. So x equals 4. 3y equals 10. Subtract 4 to both sides, we'll get 3y equals 6. Divide by 3, we'll get y equals 2. So
note that we will get the same result. So with this example, we showed that we can eliminate our x first, or we can eliminate the y. Although if you compare the two methods, the two solution, it's better for us to eliminate x because we just have to multiply one of the equations and we were able to solve the system. Comparing to this solution, we need to multiply both equations to get our solution. And of course, don't forget to verify your answer. Okay, example number 5. For this example, we can either eliminate x or y. So it depends on your preference. So if that's 2y, I would like this to be equal to negative 2y. It means that I will multiply the second equation by negative 2. y negative 2, so that this will become negative 2y, and once I add negative 2y and 2y, the y variable will be eliminated. Okay, so I'll just copy my first equation, x plus 2y equals 4. Negative 2 times 3x is equal to negative 6x. Negative 2 times y is equal to negative 2y. And then negative 2 times 7 is equal to negative 14. Adding the two equations,
We will end up getting x minus 6x is negative 5x. 2y plus negative 2y will cancel out. 4 plus negative 14 will be equal to negative 10. Divide by negative 5, and we will get x equals 2.
next we can use either the first equation or the second equation. This time I'm going to use the first equation. So from the first equation,
We will have x plus 2y equals 4. Replace x by 2. Subtract 2 to both sides. We'll get 2y equals 2. Divide by 2. Then y equals 1.
so here we have another one solution, 2 comma 1. And again, don't forget to verify your answer. Alright, example number 6. Okay, it seems like for this system, we need to multiply both equations so that we can create matching terms. So let's say we would like to get rid the x variable. So the coefficient of my x is 3, and the coefficient of my x in the second equation is 4. So we have to get the least common multiple of 3 and 4. So the LCM is actually equal to 12. So our goal is to make this equal to 12 and make this equal to negative 12. So how can we make this equal to 12? Multiply it with 4. So now 4 times 3x is 12x. 4 times negative 4y is negative 16y. And then 4 times negative 3 is equal to negative 12. Next, I'm going to make this equal to negative 12. So I'm going to multiply by negative 3. So negative 3 times 4x is negative 12x. Negative 3 times 3y is negative 9y. And then negative 3 times negative 4 is equal to positive 12. So let's add the two equations. These two will cancel out. We'll have negative 25y equals 0. Divide both sides by negative 25. So y is equal to 0. Okay. Next, we can either use the first equation or the second equation to solve for x. Let's use the first equation. So 3x minus 4y equals negative 3.
If y is equal to 0, we will get negative 4 times 0 equals negative 3. 3x equals negative 3. Divide by 3, we'll get x equals negative 1.
In this case, we will have one solution, negative 1 comma 0. And again, please don't forget to verify your answer. Okay, this time let's show how to verify our answer.
So I have 3x. Let's verify. So 3 times x, my x is negative 1. Y is 0. Is this equal to negative 3? That's 3 times negative 1 is negative 3. That's just 0 equals negative 3. So the first equation is correct. Let's check the second equation. 4 times x, my x is negative 1, plus 3y, our y is 0. That's negative 4. This is 0 equals negative 4. Again, correct. Therefore, we will be confident that this answer is correct.
Example number 7. Here we can either eliminate x or we can also eliminate y. I think I'm going to eliminate the y variable. So that's negative 14. I would like to make this equal to positive 14. So how can I make this equal to positive 14? Multiply by positive 2.
Alright, so we will have 4x. That's 2 times 2x. 2 times 7y is 14y. And then 2 times 4 is equal to 8. I'll just copy the first equation, negative 4x, negative 14y equals negative 2.
Let's add the two equations.
So negative 4x plus 4x is 0. Negative 14y plus 14y is also 0 equals negative 2 plus 8 is equal to 6.
This is a false statement. It means that we don't have a solution. It means that these two lines are parallel lines. Okay. Example number 8. So let's say we would like to eliminate our y. So I'm going to make this equal to negative 12y, and I'm going to make this equal to 12y. To make this equal to negative 12y, I will multiply by 3 to make this equal to 12y multiplied by 4. So
First equation, we'll get 9x minus 12y equals negative 9. Second equation, 4 times 4x will be 16x. 4 times 3y is 12y. Negative 4 times 4 is negative 16.
adding the two equations, 9 plus 16 is 25x.
This will cancel out. We'll get here negative 25. Divide by 25 both sides, and we'll get x equals negative 1.
Next, let's use either one of these equations. I'm going to use the first or the second equation. I'll use this one. So 4x plus 3y equals negative 4.
So x is negative 1. This will become negative 4 plus 3y equals negative 4. Add 4 to both sides, we'll get 3y equals 0. Divide by 3, we'll get y equals 0.
So our answer is negative 1 comma 0. Alright, let's try to verify our answer.
Using the first equation, 3 times x, 4, negative 4 times minus 4 times y, which is 0. This is equal to negative 3. Well, this is 0. That's 3 times negative 1, negative 3. It is equal. Okay, the first equation is correct. For the second equation, 4, x equals negative 1, y is 0. So this is 0. 4 times negative 1 is negative 4 equals negative 4. It is also correct.
Therefore, we can guarantee that this solution is correct. Alright, let's have example number 9. Okay, example number 9, we need to rearrange our terms so that we'll have standard form. So let's write this as standard form. So when you subtract x to both sides, you will get negative x plus y equals negative 6. This one, I can just use our commutative property. Switch your y and negative x, so we'll get negative x plus y equals 7. Let's get rid of the variable x. If I'm going to make one of the x's to be positive, then once we add, then the x will be eliminated. So I'm going to multiply this by a negative 1. So I'll just copy my first equation, negative x plus y equals negative 6. For my second equation, I will have negative 1 times negative x, that's positive x. Negative 1 times y is negative y. 7 times negative 1 is negative 7.
Once we add, we'll get 0 here. 0 equals negative 13. So 0 equals negative 13. Well, this is false. So we are going to say that
for example number 9, it's no solution. Okay, and finally, example number 10. Well, we already have a matching terms, actually opposite terms. So once we add, x will be eliminated. Well, in this case, same thing with the y variable. So 5 plus negative 5 is also 0. Alright, in this case, I have 0 equals 0. So this is true. This system has many solutions. Okay, there we go. That's our system of equations using elimination method.
Math is a wonderful thing. Math is a really cool thing.